Good day, everyone, and welcome to our presentation. First of all, I want to thank you all for coming here today. And now let me present to you the results of our research of information provision of monitoring the sustainable development of the land and biodiversity. During this presentation, we'll consider the main problems of monitoring the sustainable development of the land and biodiversity, the main databases we can use for this, and the main approaches to appropriate data collection. In this report, we would like to concentrate on the fact that there are completely different approaches to data collection and construction of biodiversity observing system in the world and in Ukraine. First of all, it must be said that biodiversity is a key theme of the United Nations Agenda for Sustainable Development 2030. Our research is primarily related to monitoring the achievement of the Sustainable Development Goal 15, abbreviated SDG. In order to achieve this goal, conceptual block diagram of information provision for the regulation of sustainable development of ecosystems and biodiversity was shown in our research. It characterizes structure and sequence of operations aimed at justifying management decisions. It should be noted that the main phase of this diagram is formation of a unified system of metadata that are international standards, classifications, and unified definitions of phenomena and processes that summarize modern world experience. A big problem is that many international statistical classifications are not used in Ukraine. During the research, many differences were found between indicators for micro, meso, and macro levels. Such differences make each set of indicators interesting to study. A necessary condition for ensuring a systematic study of sustainable and responsible use of ecosystems and restoration of biodiversity is the formation of a unified open database as an information source for ensuring management. This database should be able to be used at micro, meso, and macro levels. And now I want to tell you about microdata. Company reporting is an important source of data for monitoring system. Accounting data for the formation of key indicators should be collected at the level of an institutional unit and aggregated by the region. Institutional units usually consist of several different units that produce different products or services and have different locations. In the system of national accounts, they are called establishments or local kind of activity units, LKAU. This is especially true for large enterprises. It is useful to collect and compile environmental indicators for each facility first, and then aggregate the reporting of institutional unit. It was about approach to data collection. And now let's see what about the indicators. Development of a unified list of main indicators for reporting by institutional units was initiated by United Nations Conference on Trade and Development in 2016 and extending it in 2017, 2018, and 2022. In 2022, in the ecology group of indicators of the micro level, was added subgroup B6, land and biodiversity, which includes indicator B61, lands used near biodiversity sensitive areas. This indicator is defined as you can see in the slide. Among the potential sources of information, the following were identified. The first, information about the location of key biodiversity areas can be found on the official site of KBA partnership by the link on the slide. It should be noted that for Ukraine, the information is presented for the year 200. Second, information on protected areas can be found by searching the Protected Planet Global database. You can see the link on the slide. Let's now look at the next slide. Special attention should be paid to the fact that now it's impossible to receive reliable results of biodiversity research without joining effort of biologists and modern specialists in statistics. The data revolution, which includes the open data movement, new ICTs for data collection, and the availability of big data, together with the emergence of artificial intelligence, has led to a radical transformation of society. Real-time mobile population positioning data and high-frequency satellite data are just main examples of big data that can be used to monitor the achievement of SDG 15. This leads directly to our next point. One of the main projects aimed at integrating the development of big data for monitoring, evaluation, and policy development within Group on Earth Observations Biodiversity Observation Network is United Nations Biodiversity Lab, a geospatial information platform that maps natural sources and monitors environmental risks in real time using existing data and new digital technologies. As part of the above-mentioned project in 2022, the calculated data sets and indicators were included in the existing decision support system based on the United Nations Biodiversity Lab. Project data and indicators will be regularly updated until 2030 through the Biodiversity Lab. The results of the project are expected to provide a modern digital foundation for scaling up this forecasting methodology to more countries around the world, working to monitor progress towards SDG 15. The project envisages a widespread use of data sets in 170 countries that is presented on this slide. On the next slide, for example, the results for several main blocks are presented. Slide 10 shows changes in the forest cover in Ukraine for 2001 to 2020. Many organizations deal with forest change issues, so the definitions related to this concept are important and should be unified during the information provision of the study. Also, slide 10 shows Ukraine's land cover in 2020. The European Space Agency and Copernicus Climate Change produced global land cover maps from 1992 to 2020. The map legend contains 22 land cover classes that are briefly defined using the land cover classification system developed by the FAO. Biodiversity Intactness Index reflects the results of modeling the average number of originally present biological species expected as a percentage of their total number in a pristine ecosystem. Initially, the data was only available for 2015, but is now available in a time series covering the period 2000-2015. To summarize everything we mentioned, I want to say that information provision for monitoring the sustainable development of the land and biodiversity should be based on an understanding of the integrated use of statistical administrative data sources, metadata for their qualitative use, as well as a combination with big data, such as satellite images. The algorithms of data processing, modeling, and construction of integrated indicators would be the subject of our future research. Thank you for your attention.